Hello student, welcome to the my channel Physics in Easy Way. Now come to the next point of the chapter Rotational Dynamics, that is types of motion. First type, that is circular motion, is already explained in the first video of this chapter, and next, that is there are again two types of motions. First type, that is circular motion, second linear motion, and third translational motion. In day to day life, we come across all three types of motion. First, when any object or consider we displace from any position, then what will be the type of that motion? Next example, consider the motion of the fan as well as motion of the earth around the sun. Next, consider the wheels of the bicycle. These are the three examples of these three types. From these examples, we get an idea about the types of motion. In previous section, we already learned that is circular motion means motion of the object along circumference of the circle. Means any object can revolve around another object, that is the circular motion. Means motion of the fan, motion of tip of the fan. Consider the next type, that is when a man goes from this village to this, then a displacement is from this position to this position. This form of motion is called as a linear motion, means that object linearly displaced from the initial position and reaches its final position in certain time. That time, that object must have its velocity. It has its displacement. There may be acceleration, etc. These concepts are considered in the linear motion, or these are the essential facts for the linear motion. Let's take the third type, that is when wheel of the bicycle rotating about itself and moves in the linear format. That means it moves about an axis of rotation which passes through its center, as well as it moves in the linear direction. Therefore, it is the combination of linear motion and rotational motion. Therefore, it is called as a translational motion. There are number of examples around us, that is of circular motion, linear motion, as well as translational motion. Consider an object performing circular motion along this trajectory. When that object starts from its motion from this point, it has linear velocity in this direction, where OP is the radius. We can also explain that radius as the radius vector or position vector, because this radius gives the position of that particle on the circumference of the circle. Now next point, that is UCM or uniform circular motion. What is mean by uniform? This word already known to us, that is uniform means same for all. Where uniform means uniform speed, or in this motion the speed of that object is constant. Which are the examples of uniform circular motion? That is the motion of earth around the sun, motion of tip of the minute hand, motion of electrons around the nucleus in fixed orbit. This magnitude of acceleration is already known to us in 11th standard. That is, acceleration is equal to omega square into r, where omega is the angular velocity of that object and r is the radius of the orbit. These two forms are due to the relation between linear velocity and this angular velocity. In this motion, the speed of the object is constant, but the velocity of this object is also constant, but direction of the velocity goes on changing. Therefore, there is a acceleration. Acceleration is the vector quantity which depend on magnitude as well as direction. The direction of this acceleration is towards the center of that circle. Therefore, it is called as a centripetal acceleration or radial acceleration. In next video, we will come across the next point, that is non-uniform circular motion. Keep watching, like, share and subscribe my channel.